Hello everyone, we are Team 22. It's our pleasure to be here to present our group project to you. The title of our project is Winning Prediction of Dota 2 based on machine learning algorithms using hero ability data. First of all, we will go through a brief introduction. The first part is about the background of Dota 2. Dota 2, short for Defense of the Asians, is a mobile game which has a great popularity around the world for a long time. The abundance of players of this game lays the foundation of Dota 2 to be a professional esport. Thus, a lot of researchers have paid attention on Dota 2 result prediction. Secondly, we will talk about the Dota 2 mechanism. In Dota 2, 10 players form into two teams called the Radiant and Dire. Those two teams are matched against each other on a map, like the image on the right side, with two different bases that need to be occupied or defended. The team who destroys the enemy's ancient building wins the game finally. Also, each player is supposed to choose a hero from a big list of 113 different characters in the draft stage. All heroes have different attributes, roles, and abilities. The draft stage is very important in Dota 2 because the playing strategy largely depends on those heroes chosen. For example, some heroes are weak on the early stage, thus they need to avoid combat at the beginning of the game and try to earn more gold to get essential equipment to win the game. As for the goals of our study is to explore the possibility and potential of winning prediction based on owning hero information. More specifically speaking, our study has following two main goals. Firstly, compare the accuracy of three machine learning models. They are MLP, logistic regression, and DNN. We try to find the model has the best performance in Dota 2 winning prediction. Secondly, we want to compare each model's performance with adding 9 hero attributes of each hero as input feature or not, exploring whether those attributes are helpful for us to improve the prediction accuracy. There are 3 models that are related to our work: MLP, logistic regression, and group comparison using DNNs.
Yes, in next part, I will give you a brief introduction about the data processing that we have done in this paper. So you can see here, for different heroes, there are 113 different IDs for them, and each of them has its own 9 attributes. You can see here's the carry, support, nuker, and etc. So that the 9 different roles can better describe the abilities of each hero, so that we want to use this one as our additional input to learn our models. So in this page, you can see that we rearrange our input data format as shown in the table. You can see that the winner team, the loser team, and also the corresponding winner role attributes, the loser role attributes, so that we can better depict the team's entire abilities by summing up all heroes' role abilities together. And then I want to introduce firstly about the MLP methods. MLP, multi-layer perceptron, is actually to define a function h equal to f x theta, where x is the current input and theta is the learned parameters, so that you actually give the function MLP a new input to learn the result h. So in our classification task, we reset our model as r equal to f dx, where d is the data distribution for the training input, so that we can got the idea about the whole hero distributions. And then we have another current input, which is composite by the 2 team attributes to form the X. And then we use the learned function F, which is represented by the MLP function, to go to the final prediction result R, for the input X. In our implementations, we actually have two different MLP models. The first one is to simply use the multiple layer models you can see here. We actually have n different layers with W wise, and also we have m layers with wise W over 2, and also have the final prediction. You can see here between the two modules, you have actually value activations, and for the final one, we will use the sigmoid activation. And the second one is actually our own model to implement the separately usage of the team heroes information and the role abilities. You can see here, we actually use the residual idea for the team attributes from the beginning, because we want to let the module get a better idea about the team attributes for the first full layer trunk. And then we will send the role attributes into the next part about the half layer perceptual part, so that we can separately learn the different attributes about the team and the roles.
The next machine learning algorithm we choose is logistic regression. Logistic regression takes a linear combination of features, then applying a nonlinear sigmoid function to them. It guarantees that the output of neural network will be always between 0 and 1. The following is the image of sigmoid function. And then we apply the logistic regression in our model to do the implementation. We use the logistic regression model in the sklearn library in Python in our project. There are two phases in total, training phase and predicting phase. As the image shown, first of all, we will take the hero's information as input feature and then multiply it with the weight that we trained from our training phase using the gradient descent. Then we get the output and net it to be handled by the net input function. And then we use the sigmoid activation function to handle this output and get our probability result. Finally, we will use the threshold function to handle our probability to do the classification. The final result will be 1 or -1. 1 represents team 1 wins the game, and -1 represents that team 2 wins the game in our project.
Also, as mentioned before, our third model will be a DNN one. Here we incorporate the role attribute information from the previously mentioned neural AC and into such model, and thus we can propose the ANAC as shown in the figure. There are two important scores here, S1 and S2, which are the overall abilities of Team 1 and Team 2 respectively. Those scores are composed of three parts: individual effects, cooperation effects, and competition effects. Individual effects are computed for each selected hero or selected attributes in the team. And the cooperation and competition are more important. They are computed for heroes in the same team or for heroes in one team against the other. Notice that for those competition effects, i.e. those from, for example, from team 1 to team 2, or for team 1 against team 2, they are asymmetric, meaning that such a value is different from that of team 2's ability against team 1, indicating the hero's different abilities in offensive side and the defensive side. To improve our prediction performance, we use several attention modules. Their attention scores and attention values are provided here. Notice that those W matrices are the learnable parameters. And basically, that sums up our introduction of the models.
Yes, in next part, I would like to give you some experiment results to for you to better understand our methods, our work. Firstly, we compare all three methods that we implemented in this paper. You can see that the MLP, logistic regression, and AC. The MLP actually got only 0.5357 test accuracy, but for the logistic regression, it can reach to 0.5966 accuracy, and even for the NAC module, it can go to 0.6026 test accuracy. And also, we would like to compare the two implementations of our MLP models. You can see here, with the residual idea and the separately sending features, you can go to the idea about the advanced MLP have the better accuracy than the simple MLP. Thirdly, we compare the results between the feature with or without 9 heroes attributes. You can see here, without hero attributes, it only got 0.5954, but with the heroes attributes, we can go to 0.5966. It actually improved the final test accuracy.
Also, as mentioned before, we have utilized the multiple attention modules in our ANAC model. Then we can visualize those attention scores and attention values and try to see what we can get, what knowledge we can get from those heroes and attributes. For example, here, using the cooperation and competition scores for heroes, we can see that for a specific game, it's Team 1's Clinks has good cooperation with both its teammates Warlock and Jakiro. While considering the competition effect, Team 1's Magnus is strong against all other Team 2's heroes except Dark Knight, which possibly explains why the match result is a victory for Team 1. We can also consider the attention values and see which hero are kind of important or not that well noticed in cooperation and competition. For example, here for the same game, Clinks shows a much larger cooperation score than its competition score. This is possibly because of Clink's second ability, which is its key ability for invisibility and really requires some cooldown. This requires its teammates to have somehow a rather strong control ability for such Clink's second ability to take place and take advantage of the opponents. We can also visualize the attention scores and attention values of those attributes. And from those plottings, we can see that a team's cooperation is often based on heroes which are as carries or initiators, while in team competition or team fights, supports, pusher, and initiators are of great importance of each team's tactics. As we have utilized multiple modules in ANAC, we further do some ablation studies for the variants of models. Here, the existing work NeuroAC can be regarded also as a variant of ANAC, which has no raw attribute information at all. And from the test accuracy shown in this table, we can see that each of our modules can help to some part of our improvement in the prediction tasks. And that basically sums up all of our experimental results. In this team project, we examined the performance of 3 models, basically MLP, logistic regression, and deep neural network for Dota2's game result prediction. But such models should also apply well on other mobile games game result prediction, because we basically utilize those heroes information and the hero attribute information. From our experiments, though our model cannot capture all the important features of a game, such as the time and equipments, but using a hero ability as additional knowledge of those heroes can already improve our model's performance on the prediction tasks. Basically, that's all for our team project report. And thank you so much for listening to it.